to show you guys the hard way about how to enter things into the computer, okay, directly in the data segments, okay, directly manipulating these data segments here, okay, and these address memory locations to go ahead and actually write things on there, right? But I cannot do that with this emulator right now. I'm going to figure it out later. Maybe I'll upload something from my phone again on a hard-code machine, right? But it is possible, and it is cool. Is it useful? It's going to take you forever, okay? But like I said, you will be in the machine, and how cool is that? That's pretty cool. But it's really the hard way, I think, is kind of redundant and not really functional. But you really get at a personal basis with the processor that I think you become more aware by doing through even those harder things. You become more aware of what's going on, so that would lead to a better understanding of actually what you're doing. Okay, and sooner or later that'll be better speed and better everything. All right, so I can't show you how to actually manipulate each individual one of these, and because with the command enter into data segment, let's say 100, okay. Data segment 100 right now is occupied by F6. I can change this individual data segment to something else, to say, I'm going to say AD, okay, I can do that. But as you've seen in the previous tutorial / rant, that this used to keep going. and I don't know why it just doesn't, it goes from 100, then it'll go to 101, then it'll go to 102, 103, 104, 105, all the way up, okay? So we can keep entering in string code. I am not going to go in every time and keep entering in, enter data segment 101, change that from 00 to EE, okay? I don't think that's proficient, especially because it used to work. There's no reason why it shouldn't work, but hey, that's life, that's DOS. So I cannot show you how to enter in individual data segments, alright? And you know what, okay, I was listening to Torvalds talk about how he started computing and everything else like that, and guess what, yeah, he went into his computer and was editing each individual data segment, okay, and he called it retarded. That's what he used to do, and I thought that was pretty daggone cool, so of course I gotta go and emulate, right? So I can't show you that. We can dump this out again by say dump 100, address 100, and yeah, you can say that F6 was up here, 00, okay, address 100 was F6, now it's AD, yes, and address 101 is EE, right? Yes, okay, we changed those two. Now I don't want to keep changing that in this particular manner, okay, especially there was an easier way, okay, so that's that. And also too, and you see in the other thing where the fill command from parameters or from range 100 to say 1, even 120, Jesus, 0, it doesn't seem to work in this emulator, okay, but in a previous tutorial you saw what that did, okay, it fills with zeros. So I can't show you how to do that with this particular machine, okay, but I am not going to go totally the easy way, which is say by the editor, okay, because that's cool, that works, it's easier, even though this is hard enough, why make it harder, right? But let's get personal with the machine, let's go as deep as we can go, let's go to that level. I am going to show you how to enter something in directly from debug, okay? We're going to create a simple hello world program, and the conventions are a little different, syntax is the same, alright? So we're going to say put our assembler at 100, enter, okay? You will see here now we're at 100, and right off the bat we're going to say jump to 120, and why are we jumping to 120? Because I'm anticipating putting a string that is not going to be more than 20 some bytes, okay? Not 20 bytes even, but that's enough room for me to jump, okay? So we'll say jump to 120 right off the bat. And what this actually is doing, in a literal sense, is skipping over or jumping over a data string. Alright, in our string that we're going to type out, our defined bytes, we're going to type out, hey Joe. Okay? Now, we want to encapsulate that, okay? But at the same time, remember what I said about standard out and standard in. This is not a file that we're naming, this is a string of data that we're sending to the screen, okay? We just want this to print something out. It's not referring to a file or naming a file or anything else, okay? So the standard convention is a $ at the end of that. If you do not put a $ here and you just encapsulate it, what will happen is your computer will read, when your computer comes down, it's going to read, hey Joe, okay, and find no terminator, no string terminator. Finds no string terminator, it's going to keep reading 102, it's going to read to 104, 107, all the way up to the end of our program. Well, our whole program is not a string that we need to put in standard out. And what it's going to end up doing is putting out our machine code on the screen. So you're going to have, hey Joe, funky crap, funky crap, funky crap, okay, until the end of the program. And that's not what we want. Now, the $, like I said, is a string terminator, okay? But the $, also, in ASCII, the ASCII is the $, but in hexadecimal, the $, is also the number 24. I like to use the number 24. Why? Because I'm an idiot. So we can say, hey Joe, and remember the ODOA. ODOA for new line. OD, I think it might be new line. OA might be a line. A line is when I say, like in a row, you want to align things to the left. Okay? So let's throw in OD. Actually, you want to say, hey Joe, encapsulate, comma, space, OD, comma, space, OA, comma, space. And then add the number 24 for our string terminator. Okay? Now, why doesn't this here pump out the machine code ODOA? Well, it won't, because this here pumps out our string, our physical, literal string that will come out on the screen. This signifies the new line, okay? And at the new line, this is stopped by a null terminator, or a string terminator, okay? So that's what happens there. Now, let's put that in. We'll hit enter, and you see it moves us to a new address. The new address is at 10C, okay? At 10C, we'll hit enter again. Now we'll get back into the mode where we can move our assembler, alright? And you see here where we jumped to 120. Actually, what we did was, before in the edit .com file, we would send in the commands to move and blah blah blah. We would put these commands in, move AH09, which is move string into your A high register, okay? Move into your DX register. We used back then the address of 200, but this address, as you can see, is not 200, it's 102. So we need to move that memory address of 102 where our string is located in, okay? And int 21 is to execute that int 20, okay? Now I'm going to pause here for a second. Basically, instead of the edit profile, or the edit file that we had, the edit.asm, the assembly file that we made, this here was signified at the bottom of the pile, okay? What we did was we actually moved everything first, or told everything we were going to move it first, and told where we were going to put the memory location, okay? We guessed. But here we really don't have to guess, because we are going, as we're going, we're seeing where the memory location is popping up and everything else like that, okay? And two, we set our assembler to 100, and right off the bat, as soon as we jump into 100, this jumps over. This jumps right over this string here that will not be read. Jumps right over this down to 120. Okay? So as soon as we open it, it jumps right into the code. As in the edit.asm file, this jumped, or we started off just with this. Okay? So basically, you are giving this a memory location, but instead of it being at the bottom of anything, you're going to put it right at the top. Okay? And by jumping over this, you're still holding the place value of this. Okay? So this still gets a space in memory. Okay? And that's that. So this is a little harder way to do it, but it's an interesting way to do it as well. And now we'll hit enter, and we'll jump out into the command mode of the debugger, and we have a hex calculator. Okay, this slims us up a little bit. Hex, H for hex. Okay, And what you want to do is, we want to type in first where we left off in memory. We left off in memory at 0129. Okay, 0129. Okay, that's where our byte counter left us off at. Now, where did we start in memory? We started in memory at address 100. So it's a little calculator that's default on debug, and we type in where we started at was 100. Okay, and what we get left over is 029 or 029 bytes. So pretty much this is tight packed as it can be as far as efficiency and byte count. Okay, it's squeezed. Right, we kind of say squeezed all the air out of it. Okay, so if we have 29 bytes, we have to write it to somewhere. We have to put it in a register somewhere. So we'll say RCX. We want to allocate 29 bytes into RCX. So we'll say 29 bytes into RCX. Okay. Now, when we say name this file, we're going to name it himom.com. Okay, and let's write it. Okay, and as you can see here, this is wrote 29 bytes to the file name himom.com. Now, can I screenshot this? Sure enough. Select host desktop. Okay, go. Bang. Bang. Let's put that somewhere nice, like in the same folder we're working on. Right? Desktop. Files. I'm not going through all that. Screenshot PNG. How about debug? Okay. And I'll come back to this in 1 second. That's basically what happened here. Let's see if this works. Quit. Clear. Directory. We see himom.com is there. Let's type in himom.com. Hey Joe. Okay? So that's another way to write. That is pretty much the old-fashioned way to write. Say even some DOS might not even have an editor. But what you're doing is you're writing directly into memory. You're not using it by way of editor. You're not using it by way of anything else. You're writing directly onto memory. Everything you put down, everything you put in there is directly to memory. Like I said, if you don't think that's cool, you're on drugs. Now, what I would like to do is, of course, I'm going to have to stop something. I want to go back and pull up that picture that we can look at it. Nothing ever is where it's supposed to be. It's never supposed to be. Where the hell is it? Nothing is ever where it's supposed to be when you're doing a video. CD desktop, and let me say ls grep. What the hell do we call it? Debug. Debug png xd xdg xdg open debug png. Okay. Now, like I said before, there we go. That's so cute. Oh, I can actually stretch this window. How amazing. Give me some breath here. Don't hate on me. I'm trying to make this better. I can't use a mouse. I'm an idiot. Now, like I said here before, basically, well, nothing's basic with me, right? Basically, let's go into our edit. Let's go edit something and look at it. Dir, clear screen, dir. Okay. Let us do this. Let's say, this is how you delete files, by the way. Del, if it's a file, you say delete or del. If it is a directory, you can say delete tree. Okay. Let's be an idiot and try to delete tree with these. Hi, .com and himom.com. Okay? Sure. Okay? Dir. Okay? So del tree worked on that same as del would have. Or actually, no, I don't think it's del. I think it's remove or rmove, or I don't know. It's not important. Okay? Let's get this a little bigger. case someone has teeny weeny eyeballs. Okay, let's say clear, dir. Let's go up, that works. Let's go into, what was it, junk maybe? CD into junk. Edit junk.txt. Edit junk, maybe. No. It does not matter. CD2. Right? Sure. Okay, tacos, yes. Remember tacos. Let's edit tacos. Tacos.asm. Okay, now let's look at this. Let us look at this stuff. I'm sorry if that's so small that nobody can see it. My dearest apologies. But what basically is going on over here, okay, when you have an editor and you you set it to special locations, but you don't know what's going on in memory, okay, you might not be able to steer in memory, okay, so at some time or another you may be actually blind about what's going on, okay, but the thing with an editor is, it doesn't really matter, it does matter, but if you can see here, our Hey Joe program, you think about this back in the other thing, our Hey Joe program, how big was it? It was only 29 bytes of info. Over here we had to allocate 300 bytes of info. Why? Because we did not know exactly where we would pop up. Sure, we could have shrank this down to 100 bytes of info, okay? Or we could have shrank it down even to 80 bytes. But you still have how many bytes left over? 30 minus 80 is 50 extra bytes. Okay? What is 50 extra bytes in today's world? Who cares? Alright? But efficiency, it's, if you want to be like a craftsman about it, be a little efficient. You're no better than the rest of the dogs. Right? Right. Let's squeeze as much as we can out of this thing. Okay? And with the editor, as you can tell, or as I specified in the 30 seconds ago. Oh man, can I get this bigger? Oh my god, give me it. Yeah, I think that's working. Yeah, okay. This is working out fine. In the editor, we did the same thing. We jumped in and we assembled our address at address 100, okay? Get smaller. We jumped in and we started assembling right away. We set our assembler right away to address 100, okay? Now, this actually looks like what happens when you dump this into a log file through debug, okay? This shows you your memory locations. But instead of going back and seeing all that stuff, this is actually doing it on the fly, okay? Now, this location here at the instruction to move the contents, the instruction to move the opcode into the AH register, as you can see, is way down here. But how come this jump is up here? Well, even though we set the assembler to 100, right away we jumped right over this. We jumped from 100 right over our string. Now, when we jumped over our string, it still held a place, okay? And the place was at 102, okay? So as long as we can keep on, with bigger programs, you'll have a problem with this. But unless you write down your address memory locations, we are going on the fly, and even though we stepped over it, this string does have a place. This string above my window here does have a place, okay? We jumped over it, but we also gave it its place, okay? And why is that important, or why is that cool, or anything else like that? Why is that efficient? To be honest with you, it is not efficient to write in a debugger at all, okay? But this is how deep you are, okay? This is not a good way to write. This is a way that they did write at one time, okay? The editor was not always there. Obviously, somebody had to build the editor. I would like to build my own, but I'm not that smart yet. So, like I said, first right away, after we assembled at 100, we are at address 100, we jumped right over to 120, okay? 120 is the beginning of our instructions, okay? Unlike over here, we assembled at address 100, and at address 100 was our instructions, and we assembled that, okay? Now, we actually did jump, but we didn't really jump. We moved. We physically moved our assembler to 200, okay? And the same thing over here. We move our assembler to 120, okay? But this here jumps over, jumps right into the code. So actually, when this executes here, what happens is, it hits address 100, okay? This is right from the debugger. When you turn it around and you say run this program, it jumps right in at address 100 in memory, and then soon after it does that, it jumps right out, and it jumps right to move AH09. Then it says move DX102. Then it calls that memory location, which is at 102, and sticks it in there. That executes it. That exits the program. Blah blah. Okay, that's how that works. Instead of in the reverse order over here through the editor, this is at address 100, right? You say move into AH09, move into DX memory location 200, which comes down here and actually, would call 200, okay, and then comes back up in 21, executes it in 20, it's done, alright? So, what I'm trying to do is, I'm trying to say how to be more personal with where we're at here, okay? We use no editor with this. This is strictly directly, this wrote directly into RAM. This here we had to run it back through into RAM, okay? Now, like I said, the debugger is more compatible, comfortable, okay? This is true, and I'll be using the debugger for more purposes and later on, alright? But this is sweet. This is sweet. But this is archaic, old, ancient, and it's like you gotta be like a real man. Well, actually, we can't be a real man because we can't enter in data segments. Not on this computer. Alright? Well, I really want to do that. And I will. But down to here, this is a new feature that we did not discuss or talk about before either, was the H. Let me shrink this up from now on so you guys don't have to look at all this crap. Okay? Let me shrink it up even more. Oh my god, I can go that small with that. It's freaking amazing. Down here is the H, okay? The H stands for hex, or it's like a simple hex calculator, okay? And like I said, the only thing that this does here is just pulls all the air out of it, pulls all the bloat out of your system, okay? Because, byte-wise, 29 bytes, or say 70 bytes of bloat, I don't know, you think about that. If this is only 30 bytes wide, our program was only 30 bytes wide, the bloat that we had in it, or would have left in it, would have been 3 times the amount. If we allocated, say, 100 bytes of information, this would be 2 times as heavy, alright, than it needs, or 3 times as heavy as it needed to be, okay? And that is not cool. It's a good practice maybe to squeeze all the air out of your stuff. Alright, it's efficient, it works better on machines, it's not a draw, okay? It's a good thing, alright? It's a good thing with a Hello World program, who cares? But if you get into practice even on a Hello World program, when you go into something else, like, you know, actually building something, if you can squeeze as much air as you can out of the system, you're going to have a nice little OS going on, alright? This is a hex calculator. Hex calculator takes, first of all, it takes the ending position where you ended up, okay, hex, which you ended up at the address 0129. Now if you had ended up in the address 012C, then you would put 012C there, okay? But where was your position when you started? You started at position 100. Of course we did, up here, okay? And what this does is does a little calculation for us and puts us there. I don't know why this 0229 came out. I have no idea. On my other machine, my physical machine, that doesn't happen. The only thing that does come out is the 0029, or slightly 30 bytes, okay? Now here we edited the CX register to add 29 bytes of data in, okay? That's the same thing like we did with our DOS program that we ran in our edit program. Okay? Same thing. Except here, instead of 30 bytes, we added 300 bytes. Okay? Okay. So, that's what happened there. Of course, the same thing. Our name, our write, and it wrote, and our quit. Okay? So that is just another way. This is a harder way to program, but this is punching right into memory without the use of anything else. It's just punched right into memory and turn right around and you're running. Okay? So actually, compilation. Is it compiled? This gets punched right into memory. As soon as you exit it or write it, it's there. It must be compiled in some sorts, so it gets compiled directly into memory. So maybe so. Okay? And I'm not going to get about how DOS likes to just throw it on the hard drive, because that's exactly what's going on in this instance. You know that. It's being thrown at the hard drive. Okay? And is it bad for you? Who knows? But, like I said, the problem with this, though, is if you get into a situation, let's do this. Debug, assemble at address 100. Okay? If, actually I have to type in regular commands, huh? Blah. Okay. Let's not do that. We're going to say debug, dump. Okay? Let's say u. Okay, that's better. We'll stick with u. Quit, clear screen, debug, u. Say if this was some fantastic ass code that we just fucking created. Okay? We wrote the heck out of it and blah blah blah. Alright? We had our jumps in place and everything else like that, just how we did in the previous not previous tutorial, but when we just created our hello world file with the jumps over everything. Okay, if we had this up here and blah blah blah, and we were rocking along, and you know, you got whatever you're listening to on your thing, you know, and you're having a good time, and code is just sweet, and everything is great, and the sun is shining, and all this other stuff. What happens when you need to go back up, and let's say that this would be a string, which is not a string, but say this is a string in 11C, okay? And you're rocking and you're rolling and everything else like that, and you go ahead and, oh my god, where was my string? Okay? As you can see, 11C is far gone. We are now here with the alarming fact that we just lost where we stored something in memory. Alright? Now with any other machine that does not write directly to RAM in your hard drive and throw it at like a big can of sardines, we could scroll back up, right? Well, that's not the case in DOS. I don't know if you noticed that yet or at all. But you can't scroll back up and go find out where your data's at, okay? So it would be a good idea, if you're going to do it this way, if you want to do it the hard way, it would be a good idea to write down some memory locations, okay? Because they're there, you just don't know where they are. Okay? And that's that. Alright. That's all I'm going to say for this tutorial. Just wanted to show you guys a harder way to do it. But it's harder, but it's more in depth. You know what I mean? It's very, very, very cool. Because we're down this low. Might as well go lower if we can. Let's see what happens when we say T, 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 no, R, no, T. Unassemble anything. I don't know. Alright. So, hope you guys dug it. And I am done. Have a super... Oh, exit this, man. Have a super day. Kill PSOX. I think I'm going to refuse to get a button. This is my sign out signature type of thing. This is what I do. This is how you know it's authentic. Nobody's telling you to kill the rabbit.